Today, on how it's made. Halogen bulbs. Making them is a really brilliant process. Cellulose insulation. We bring you wall-to-wall coverage of this construction material. Aluminum ladders. We'll go to the factory to tell you how they get to the top. And bamboo fly rods. We cover all the angles in the story of how they make them. Halogen headlights are a shining example of progress. The halogen bulbs throw cool white light that mimics daylight, illuminating the road ahead. And because they're energy efficient, they don't burn out too often. That's a plus when you're trying to keep your eye on the road. To make a halogen headlight, mechanical jaws load 3 lead wires into a machine. A gripper moves in and bends the wires at the bottom. Meanwhile, a conveyor system feeds little glass rods to a burner. The softened glass is now pressed onto either side of the lead wires, encasing them. Next, a welding head fuses tungsten coils to the lead wire assembly. The coil is the filament, the part of the bulb that emits light. Over at another station, a mechanical arm loads a glass tube into a machine head. A burner aims a flame at the center to soften it up. Then mechanical heads pull the glass at both ends as the burner continues to fire heat at the middle. This creates a neck in the tube. Now mechanical arms position the coil and lead wire assembly under the newly shaped glass tubes. Grippers lower the glass tube over them so they sit under the neck. Burners move in and encircle the glass at the bottom, softening it. Then a press seals the glass around the lead wires, which protrude from the bottom. Next, a test. An electrode sparks the lead wires. When the capsule illuminates, it means there's ambient air inside that would interfere with the bulb's function. Vacuums at the top of the bulb suck out all the air and contaminants. Then nozzles spray liquid nitrogen onto the bulb. This freezes it inside and out, creating a pressure difference. That change in pressure pulls halogen gas into the bulb from a chamber above. Allowing no time for the gas to escape, burners heat seal the bulb at the neck. The bulbs then cool as they move on a transfer chain. Grippers now load the bulbs into another machine. A pusher moves up and snaps a steel retainer around the bottom of each bulb. Meanwhile, another machine builds the base for the bulb. It pushes electrical contacts into the plastic receptacle. This is the view from the bottom. These prongs will eventually connect the headlight to the vehicle. Next, jaws flip the bases. They load them onto a tray on tracks. The tray delivers the plastic bases to a mechanical arm that installs metal retainers on each one. The bases slide forward and the machine inserts the glass bulbs into them. But it's a loose fit. This machine aligns each bulb to its base. Jaws tilt and slide it into place, then a laser welds it together. This alignment is critical. Coils for the low beam and high beam mechanisms must be precisely positioned for the headlight to project the right light. Next, a series of claws pick up the bulbs. They dip them in an opaque coating. It's called blacktop because it only covers the tops of the bulbs. This will direct light out of the sides of the bulb. Now it's time to take these headlights for a test drive, so to speak. A bracket holds them down, while probes underneath energize them to make sure they work. A plunger places a gasket around the base. This will seal the headlight capsule to the automobile. And now, they're ready to shed some light on any highway situation. Insulation keeps your home warmer in the winter and cooler in the summer. One type of insulation material is cellulose fiber, made from recycled paper. It's derived from a natural source, wood fiber, so it's non-polluting. It contains no asbestos, no fiberglass, and there's no formaldehyde in it, so it doesn't emit any gases. Like other insulation materials, cellulose fiber has to meet strict government safety standards. One fire safety test assesses what's called smolder resistance. The company lab weighs a sample from the production line, then inserts a lit cigarette in it. Once the cigarette burns out, which takes an hour or two, the lab weighs the sample again. The weight loss must be less than 15%. How they make cellulose insulation isn't very complicated. It all begins with recycled paper, delivered in bulk. Workers load it onto a conveyor belt, and from that point on, the entire process is automated. The paper first goes into a machine called the primary mixer. It separates the bunched up pieces, preparing them for shredding. The machine's powerful magnet removes staples, paper clips, and any other pieces of metal. From there, the paper goes into a shredder, which rips it into pieces about 5 centimeters long. The factory mixes the shredded paper with boric acid, a natural compound that acts as a fire retardant. It also makes the insulation pest resistant, and it helps fend off mold, wood decay, and corrosion. Now a machine called a fiberizer shreds the paper into tiny pieces, only about 4 millimeters long, and it mixes them with more boric acid. From the time the recycled paper arrives by truck to the time it comes off the line as cellulose fiber insulation, only about 5 minutes have passed. But the insulation doesn't leave the factory before undergoing thorough safety testing. This test assesses what's called open flammability. They heat the insulation to 50 degrees Celsius to represent the temperature of a roof in the hot sun. Then they ignite it. The flame travels, but then dies out, thanks to the boric acid. If that happens within a certain distance, the insulation is safe. Outside research firms also test the product for safety to independently corroborate the results of the company's tests. The automated packaging equipment blows 11.3 kilograms of insulation into a bag, at the same time compressing the fiber into a block. Some types of thermal insulation come as thick rectangular blankets known as bats. You install them by hand, fitting them snugly between the wall studs. Cellulose fiber doesn't come in bats. It's known as loose-fill insulation. A professional installer has to inject it between the walls. By spraying it in under pressure, it fills all the spaces without any gaps, something that's hard to do with pre-shaped bats. Insulating performance is referred to as R value. The higher the R value, the more effective the insulation. Cellulose fiber insulation has a higher R value than loose-fill mineral fiber insulation, and depending on which statistics you're looking at, has either the same R value as loose-fill fiberglass or a higher R value than fiberglass. Cellulose fiber is denser than the other materials, so it better resists air movement, making it less likely to move out of place after installation. The aluminum ladder is the height of convenience. Lightweight and sturdy, it makes any ascent easier. Back in the 1930s, wooden ladders were the standard, but were extremely heavy and difficult to position. The use of aluminum took things to a whole new level. For a ladder to really hold up, the aluminum needs to be strengthened with these ingredients: silicone, magnesium, manganese, and copper. It all goes into an enormous furnace. It takes a crane to transport a hopper full of aluminum over to the furnace. The hopper opens at the bottom to unload. A worker opens a door at the front of the furnace. He wears a face shield to protect him from the blistering 700 degrees Celsius heat. He adds the other ingredients, and the heat turns it all into a liquid mass. The liquid flows out of the furnace into troughs. It seeps through holes in the troughs to molds in the ground. The liquid cools and hardens in the molds. This makes log shapes that are almost 7 meters in length. A hydraulic lift extracts them from the molds and slowly takes them to the next station. You wouldn't want to rush this job. Each log weighs 500 kilograms, and dropping one could do serious damage. A saw cuts them into pellets. The size depends on the type of ladder being made. A mechanical lift delivers a heated pellet to an extruder, and a ram pushes it into the opening. They move the die plate into position. The ram forces the hot pellet through holes in the die plate. This makes a rail shape 40 meters long. A puller drags the rail onto a table and leaves it to cool and harden. Then a circular saw slices it into manageable lengths, 6 meters. Operators feed each end of the ladder rail to jaw systems, which pull it to make it completely straight. The straightened rails now move on to the next station, where they rivet plastic feet onto the ends to keep the ladder from slipping. They stick safety information onto the rails. And now they assemble the ladder, one step at a time. Workers fit each step in the rims of the ladder rails. They rivet them into place. This will be the front of a light-duty step ladder. They install a diagonal brace and turn the ladder over to rivet the steps from the other side. It's a little more reinforcement. Then they build the back side of the step ladder. They rivet the sturdy blue plastic top onto the front and back pieces, joining the two. They install the spreader, securing it with rivets as well. And now this step ladder is ready to provide a little elevation. For a lot of elevation, they make extension ladders. They use round rungs for greater strength. They feed each rung to a coining machine, which tapers the ends. Another machine presses aluminum ferrules, or rings, onto each end. This allows the rungs to fit snugly into slots in the extension ladder side rails. Hydraulic arms reach from above and below to press fit the rungs into the side rails. Finally, workers rivet rubber pads onto the ends of the rails. This provides a firm footing for the ladder. These ladders are now complete. And if you're on your way up in the world, they'll come in handy. The bamboo fly rod is a classic. The split bamboo rod has been around since the early 19th century, and for many years it was the only kind of rod available. These days, synthetic rods abound, but bamboo still holds a traditional appeal. People buy the idea, hook, line, and sinker. Fishing for compliments? A bamboo rod is considered a work of art in fly fishing circles. To make one, a craftsman toasts a bamboo pole on an open flame. He holds it close to the fire, but not too close. One false move, and he could scorch it. The goal is to turn the bamboo a golden brown. He pounds a wedge into the toasted bamboo and drives it down the length of the pole. He pulls the pole apart, splitting it in two. Then he continues to split the bamboo, making strips that are less than a centimeter in width. He grinds down the bumps on the exterior of each bamboo strip using a belt sander. Next, it's over to the milling machine. It tapers the underside of the bamboo strip, beveling it to a 60-degree angle from end to end. The tapering is a critical step that will affect the rod's casting performance. Each strip has to be perfect. The rod maker inspects them for flaws and then fits 6 together in a hexagonal configuration. He wraps them with cotton twine to hold them together very loosely at one end. Then he dips the bamboo strips in a tank of thermosetting glue. He feeds them to a twining machine, which binds the strips tightly together. It's a temporary wrap, a kind of clamp, to hold the pieces together while the glue dries. The pieces are now laminated into one, but the result is never perfectly straight. So the rod maker heats it over an open flame. The heat softens the bamboo so it can smooth out the kinks. Next, he glues ferrules made from nickel silver onto the laminated bamboo pieces. This tubing will be used to connect the tip and butt pieces of the rod. The butt section now turns on a lathe while a blade cuts into it. It's slimming down sections to accommodate the handle and reel seat. He slips on the walnut reel seat and then slides cork rings onto the rod to make the handle. He glues each ring. It takes 12 to 14 to make a handle for the typical bamboo rod. It will allow for a soft, non-slip grip. Once the glue hardens, he shapes the cork on a lathe. He sands it to give it an even finish. Next, he heats glue over a flame. He applies the hot glue to the stainless steel tip and sticks it on the narrow end of the rod. With black India ink, he inscribes the model and serial number onto the rod. Now they coat it with varnish using a turkey baster. He hangs the rods to dry. It'll take 3 coats to give them a nice gloss. After that, they wind silk thread to attach the steel guides to the rod. They're the loops that the fishing line will go through. They brush 3 coats of varnish onto the string. This solidifies the wrap. and fuses it to the rod. They slide a ring onto the reel seat. It provides a little separation from the cork grip. They fit the butt and tip pieces of the bamboo rod together and do a final inspection. It has taken 40 hours to make this bamboo fly rod. But it shouldn't take you that long to catch the big one.